right, so prior to this video, we went through and we talked about these words motion and position. And now today we're going to refer to the same notebook page, but today we're going to talk a little bit more about speed and velocity, and then we're going to discuss this word acceleration. So before watching this video, we should have read pages 414 and 415, where our textbook kind of defines for us and gives us several examples referring to speed and velocity. They even teach us how to determine the speed of an object. Then we read 416 and 417, and we learned a little bit more about gravity and then force and friction. And finally, on page 418 and 419, the textbook is talking about that word acceleration and kind of trying to give you some examples there in that table. And we'll go through that after we talk about speed and velocity. So let's jump in and get started. If you have not read those textbook pages, you'll need to pause this video and then come back after you've read and you're ready to talk about speed and velocity. All right, so we're going to flip this section open, and just like before, guys, try your best to follow along. At the end, I will pause the video, and I will open up each of these flaps if you need time to record these definitions and descriptions. So I'm going to write the word speed here, so that when I open all of these, I know which word I'm referring to. So speed, well, we kind of know what speed is. Our background knowledge helps us to kind of understand speed. But when we think of it in relation to science and how scientists would describe speed, speed is how the position of an object, changes. Now, that kind of sounds like motion, but it's a little bit different because we're going to add something here. So how the position of an object changes during a certain amount of time. So during a certain amount of time. They even gave you a formula, so we're going to try to simplify that. The formula that we use to determine speed is distance, meaning how far it goes, and we're going to divide that by time, how long it takes to get there. When you divide the distance by the time, you are calculating the speed of an object. So once we know speed, then velocity is pretty easy to describe. If you read in the text, then you recognize that velocity is really just the speed of an object, but it also describes which direction it's traveling in. So let's write down this word velocity. And that is the speed of an object in a particular direction. So the speed of an object in a particular direction. So they gave an example in the book, right? If you were walking. So if you are, let's write example, walking, headed east. So if you're walking headed east, so the velocity could be, maybe you're walking 2 meters per second, and you're traveling east. So that right there would be an example of velocity. That's your distance per the amount of time it takes you to get there in the direction you're traveling. Okay. Give you guys just a moment. Then we'll talk about acceleration. All right, so I think acceleration is one of the terms that is sometimes confused, and I think that it's frequently misused when describing the motion of an object. So let's fold this one back and let's write the word acceleration. I think that what happens is that when describing acceleration, people automatically think of like a vehicle, a car or a truck or a motorcycle, and they think of the word accelerate and they think of it as just speeding up. But really, scientifically speaking, it's any change in velocity. So any change in velocity. So we learned that matter, an object, really, it's an object or a person, but matter accelerates if it speeds up, slows down, or changes direction. So that's the tricky part. I feel like right here, these two parts here at the end, that's the part that maybe most people are not aware of when they're using the word acceleration. So I will share this page with you in just a moment. I know some of you are still getting caught up. That's okay. I just want to take a quick peek at your textbook. When they were describing acceleration, they gave you the example of this fly, and it was changing its speed, it was changing its direction, and you had to describe, or you were learning more about this word acceleration. So here it was speeding up, so it is an example of acceleration because it is increasing its speed. Here the fly is slowing down. So because there's a change in speed, which is part of velocity, it is also an example of acceleration. So here the fly is now turning and it's speeding up. This is another example of acceleration. Right here where it starts and stops. Because it's going to slow down and then speed up again, this is also an example of acceleration. And then right here where it's changing direction, it is also accelerating. But I want to look at this table for a minute, guys. So maybe you did this, maybe you did not. That's okay. We're going to go through this quickly together. You had to decide whether this was providing an example of acceleration. So let's look at the first example here. We'll label that like number 1. So we have a mouse and its speed. It's traveling 1 meter per second. And then what happens? It's suddenly chased by a cat. So, what is happening? Well, if you're suddenly chased by a cat, I would assume that there's going to be some change in direction. I would also assume that you're going to speed up. So I would say yes, this is an example of acceleration because our mouse is probably going to at least speed up. Let's look at the second example. So we're talking about a runner, and the runner is traveling at 8 meters per second. That's its speed. Now what happens? It runs at the same speed around a circular track. Well, so it's traveling at the same speed, so that doesn't necessarily indicate acceleration. However, this part right here, around a circular track. Well, if you just looked at the circle that Mrs. Body drew around these words, you can see that it changed direction. It didn't just stay in a continuous straight line. So is this an example of acceleration? Yes, because there's a change in direction. So changes direction. Now let's look at the third example. We're talking about a train, and it's traveling at 80 kilometers per hour. That is the train's speed. Now, what happens? It continues to move along a straight track. So is this an example of acceleration? Well, no. Because the velocity and direction are constant. Now, if you had something else written here, if you went ahead and tried, you filled this out yourself, but maybe your answers are slightly different than mine, don't stress, okay? That's why we're going through it together. There weren't really clear directions on how to complete this. That's why we're talking about it now. The last example, a jet plane that's traveling at 300 kilometers per hour. Now, this is interesting. We have to determine what happens. They're telling us, yes, there is going to be an example of acceleration. It's slowing down. So what do you think is happening with this jet plane if it's starting to slow down? Those of you who have ridden on a plane before, you probably have background knowledge and you might know what's happening to this plane. Great. Chances are it's probably coming in for a landing. We know that if we're coming in for a landing and we're on a plane, yes, our speed is probably going to have to slow down. All right, so I told you guys that I would go back and I would share with you that page. So I'm just going to display this, and I'm going to open up all sections here with those words defined that we just went through. Again, today we talked about speed, velocity, and acceleration. So if you need to pause the video now, then you can pause it and you can write the definitions for these three terms.